Hi, my name is Ishan. Welcome to Easy Math. And in this video, we're going to talk about conservation of momentum. A quick go through conservation of momentum is what we're going to do now. So let's see. So the most important thing about this topic is to know the uh, application of it, and it is basically this thing that you see on the screen. It's initial momentum of the system should be equal to final momentum of the system. When I say system, it's supposed to be the objects that you see in the question. You can have an engine um, running into a wagon, and you can have a ball hitting a toy, and various different objects. Mostly, there are two objects in the question. And when I say system, initial momentum of the system, it means initial momentum of the engine plus initial momentum of the wagon, initial momentum of the ball, and initial momentum of the toy together before the impact. And when I say final momentum of the system, I mean the same two objects after the impact. The two things that you want to keep in mind before you get into the question is to pay attention to the direction of the velocity. If it points to the right, we will take it as positive. If it points to the left, we'll take it as negative before the impact or after the impact. And the other thing you want to pay attention to is whether the objects are stuck together after the impact or they are moving in different directions or moving separately after the impact. These two things you're going to have to pay attention to. So now what we do is we do some questions that have come in the past papers. Let's see. So we start with a very basic question, which is about engine and truck. So they say before the collision, the toy engine is traveling at 0.32 and the mass of it is zero point 0.5. So with this, you know that the momentum of the engine can actually be found before the impact, and it's going to be these two things multiplied. You have seen the previous videos and you know that the formula for momentum is mass into velocity. So you've got mass here, you've got velocity, you multiply them, and you get the momentum of the engine before the impact, and it comes out to be let's see, 0.5 into a 0.32, it's a 0.16 kilogram meter per second. Okay. And you can see that the toy truck is stationary before the impact. So when you are calculating the momentum of the system, when you're calculating momentum of the system, which in this case is the engine and the truck together, before the impact, you know it's 0.16 from the engine. And since the truck is stationary before the impact, the momentum of it is zero. And then uh, it must be equal to the momentum of both the objects added together after the impact. And let's see if they ask for it. So the mass of the truck is zero point 0.3. Use conservation of momentum to calculate the speed of the joined engine and truck. So you know that they have stuck together after the impact. So you know that momentum of the system again after the impact, since they have stuck together after the impact, the most important thing to know is they're going to move together with the same velocity. Their velocities are not going to be different if they have joined together after the impact. So the mass of the truck is a 0. The mass of the engine is 0.5. The velocity of it, we don't know. The mass of the truck is 0.3, and the velocity of it, we don't know after the impact, but pay attention that the velocities are the same for both the objects. because we know they have joined together. And that's how you solve for the velocity or the speed that they are asking for. So 0.16 is going to be these two added, zero point 0.8 into v. So you get velocity equals 0.16 divided by zero point 0.8, and that's going to be 0.2 meter per second. That is the velocity with which the um, joined engine and truck move immediately after your impact, after the impact. So there it is. That's how you go. A momentum before the collision, momentum after the collision, for both the things together added gives you the velocity with which the things are moving after the impact. Let's do some more questions. Okay, so this is your P4 book, and we are talking about question number 103. There's a truck, and there's another truck which is moving towards it at a velocity of 5, at a speed of 5. Okay, so calculate the momentum of the truck A. Truck A has a mass of 6,000, and the velocity in the speed with which it's moving is a 3. So you are looking at 30,000 kilogram meter per second, and that is it for the truck A. You can go write down the formula also, just to be like safe in case you go wrong with the calculation. The trucks collide, their buffers compress, and then they bounce off each other, remaining undamaged. After the collision, the truck B has a momentum of 27,000. Determine the impulse applied to the truck. Okay. Okay. So the point with impulse is that impulse is supposed to be change in momentum. And uh, you see that the truck B was stationary. So what we have now minus what we had earlier, momentum final minus momentum initial. Final momentum is 27,000. That is what we have after the impact. Minus, it was truck B was stationary before the impact, so it was at 0. Impulse would be 27,000 kilogram meter per second. I think we have moved into a question from impulse instead. So let's go do some more conservation of momentum. Let's pick up some questions from P2. Okay, let's see. An object P of mass 80 grams collides with another object of mass 40 grams. After the collision, P and Q stick together and they travel together. Before the collision, P is traveling at a speed of 6 and the Q is at rest. Okay, fine. So we go do the same thing. Before impact, before impact, and after impact. We're going to calculate the momentum of the system. So you go P and Q, P and Q. P initially is supposed to be zero point 0.8 kilograms. That's 0.08 is the mass of it, because you have it in um, grams here. So I would like to convert it into kilograms. It's just a good practice, although you will end up with the right answer in this question, at least with grams there. Mass into velocity of P, 6, plus mass of Q, it's a 0.04 into Q is at rest initially, should be equal to the mass of P into velocity of P, mass of Q into velocity of Q. Since they're moving together, the speed is going to be the same. So these two multiplied and these two, of course, is a 0. So it's going to be 0.48 equals these two 0.12 times V. V comes out to be a 4, and that is your answer, 4 meter per second. Done. Okay, let's do one more. Hmm. A toy train P, mass 0.5, tr- straight track with a velocity of 3, stationary Q. Okay, so P, zero point 0.5 is the mass, 3 is its speed, Q, mass 1 kilogram, stationary right now, and they stick together. So you go 0.5 into V plus 1 into V. you're looking at 0.15, and this is a 0 equals 1.5 v. V comes out to be a 0.1 meter per second. What is wrong with what I have done? Oh, this is not a 0.15, it's a 1.5. 1.5, and v comes out to be 1 from here, 1 meter per second. Okay. What is the velocity of the combined trains? 1 meter per second, of course, it's one out of these two. Same direction as P and reverse direction as P. C. With P, the velocity of it taken as +3, and the final velocity also coming out to be +1, both of them are supposed to be the same direction. The velocity initially for P and the velocity finally for P, since both of them have come out to be the same sign, they are moving, P continues to move in the same direction. And that is why the correct option is A. If by this calculation the velocity had come out negative, I would have taken it as B here. Okay. So you want to see the sign of the velocity that you take. Okay. Now let's go do one more. Okay. What do we have here? A ball of mass 0.16 kilogram is moving forwards at a speed of 0.5 second. Ball is stationary. Okay, ball number one, ball number two, ball number one, ball number two, 0.16 into zero point 0.5 and zero point 0.1 into 0 is equal to, the first ball strikes the second ball moves forwards at a speed of zero point 0.5. So the second ball moves in the same direction, right? Forwards. So you're going to have the same velocity on same sign on the velocity for ball number two, sign as in positive. So ball number two is zero point 0.1 and the velocity is 0.5 positive. And ball number one is what we're trying to find the velocity of. So we go 0.16 into V. Okay, these two multiplied, it's gonna be 0.16 divided by, so 0.16 into 0.5. How much is that? Point 08, I think. Let's see. 0.08 here, and you have a 0 out there. Zero point 0.1 into 0 it is. So this thing is a 0. You want to add them, equals this and this. So it's a 0.16 into V plus half of that. So 0.05, and it's going to be 0.03 equals 0.16 V. V comes out to be 0.03 divided by 0.16. And I think it must be, let me check, 0.1875, and it's closest to 0.19. So 0.19 meter per second is your answer for this one. Okay, so that was another question. Let's see if we have any other question that we have selected to do today. Oh, yes, there it is. Huh. So a car of mass 1,000 kilograms traveling. So car with a lorry. So 1,000 kilograms on the car, mass is 1,000, speed is 8. Lorry also has some speed to it. It's a 2 and a mass of 3,000 in the same direction, meaning both of them are going to be positive. Uh, After colliding, the two vehicles are stuck together. So you go 1,000 into V plus 3,000 into V again. So you're looking at 8,000 plus 16,000. Oh, sorry. 8,000 plus 6,000 equals 4,000 V. Are you looking at 14,000 equals 4,000 into V? V is going to be 14 by 4. That is a 7 by 2. That's a 3.5 meter per second. There it is. That's your answer. Okay. Uh, uh, the thing to pay attention here, they're moving in the same direction, the lorry and the car. So if I put a +8 here, I want to put a plus two there. Okay. So that was another question. Let's look at another one now. Okay. There. Okay. So see how this question is different. Now the objects are moving in opposite direction. So I'm going to make sure that I use that fact. I make sure that I'm careful when I'm placing velocities into my solution. I go object 1 and object 2. So object 1 moving at a speed of 6 and a mass of 3. So 3 into plus 6. Object 2, 2 into, since it's moving in the opposite direction, I put a -2 there. And I can see that they are sticking together after the collision. So you go O1 and a O2 out there. 3 is the mass of it, V, and plus 2 is the mass of the object 2 and a V again. You're looking at 18 minus 4 equals 5V. So 14 by 5 is the velocity of the combined objects here. V is going to be 2.8 meter per second. Okay. So now that the velocity after this has come out to be positive, it is still going to move to the right. The whole system is, since we took that as positive, the velocity we have got is also going to be in the same direction towards the right. Okay, so that was a few questions. You can go try out some more questions by yourself from the P2 and the P4 book, which involve systems like these. And we can close this topic for revision. You can actually go do 449 from the P2 book and 450 from the P2 book. And of course, there are many more of them in the recent papers. Those also you can try. And that's it for this one. I'll see you. Bye bye.